Let's look at example 2. Example 2 is the square root of 1 minus 4x squared dx. Again, this is not a problem that I can handle with a u substitution or integration by parts, so it's a problem that is got a polynomial in quadratic form and something that I can use a trig substitution for. So the very first thing that I need to do is identify what I have and what substitution I would make. Well, I have a number minus a variable, and if I go back to what I've determined in terms of my substitutions, this is variable minus number, number minus variable, variable plus number. So the substitution that looks at it fits for us is this sine of theta, because that involves a number minus a variable. So the substitution that I'm going to make will be the sine of theta. What I need to do again is identify what a and u are. Well, this is my a squared. If a squared is equal to 1, that means that a is equal to 1. This is my u squared. If u squared is equal to 4x squared, that means that u would equal 2x. Following along, I need to make the substitution for sine. That means that I need to let u equal a sine of theta. In my case, I'm going to let 2x equal a, which is 1, I don't need to write that, times the sine of theta. I'm solved for sine. I can use that information to make my triangle. So coming here and making my triangle, this is theta. So I know that the sine of theta is equal to 2x. So that means opposite side, 2x. My hypotenuse would actually be 1. And then again, using Pythagorean identities, I would get that the adjacent side here would be 1 minus 4x squared. Now, again, I need to make sure that I'm replacing everything in this integral with something in terms of a trig function. So I have two things that I'm looking at. I'm looking at the square root of 1 minus 4x squared. I need to determine what that is, and then dx. So the first thing I look at is I try to determine from the triangle what is the square root of 1 minus 4x squared equal to. Well, remember, I have here the square root of 1 minus 4x squared, and the other side that I want to do is the one that involves the constant. Never reintroduce the variable. So I need something that deals with the adjacent side and the hypotenuse. Well, that would be the cosine. So I know that the cosine of theta would equal the square root of 1 minus 4x squared all over 1, which is just the square root of 1 minus 4x squared. So I can replace the square root of 1 minus 4x squared in my integral with the cosine of theta. Then I need to determine what dx is. To determine what dx should be, I'm going to go back to my original substitution here and figure out what the derivative is. Well, the derivative of 2x is going to be 2 dx. The derivative of the sine is the cosine of theta d theta. Now, I don't have a 2 dx, which is what I need here, but again, that's just a constant multiplier, so we're going to multiply by 2 and divide by 2 to get the 2 dx that is necessary. So here's my half, and again, 2 dx is equal to the cosine of theta d theta. So now I have the new integral that I need to evaluate, which is 1/2 times cosine of theta times the cosine of theta d theta. Well, that is an integral that I can evaluate. I know that that's the same as cosine squared theta d theta. And when I have just the cosine by itself raised to an even power, I know that I need to do the double angle identity substitution to work this problem out. So what I'm going to do is I'm going to rewrite cosine squared theta as 1 plus the cosine of 2 theta all over 2 d theta. Well, the 2 in the denominator here is a constant multiplier, so I'm going to pull that out. And then I have 1 plus the cosine of 2 theta d theta. And those are all things that I know how to integrate. So let's go ahead and integrate. So I have 1/4 times, well, the integral of 1 is going to be theta, plus the integral of the cosine of 2 theta is going to be the sine of 2 theta over 2 plus c. If I distribute in my 1/4, I get 1/4 theta plus the sine of 2 theta all over 8 plus c. Well, now I need to get this out of thetas and back into x's. So I have the sine of 2 theta, and I come over here and I don't have 2 theta at all in my triangle. So I know that I need to replace the sine of 2 theta with some kind of identity where I get rid of 2 theta and I go back to just theta by itself. Well, recall the sine of 2 theta is equal to twice sine of theta cosine of theta. So replacing this, I end up with twice the sine of theta cosine of theta all over 8 plus c. So I can find sine of theta using my triangle. I can find the cosine of theta using my triangle. So I have no problem there. So anytime I end up with sine of 2 theta or any double angle, I'm going to have to use my trig identities to get it back out of its double angle form. I also noticed that I can reduce between 2 and 8, so we're just going to go ahead and do that right now. All right, so now let's get again out of thetas and back into x's. So I need to figure out what is theta equal to in terms of x's. Well, that's not on my triangle because my triangle can only tell me what sine, cosine, tangent, cosecant, secant, and cotangent is equal to. So to solve for theta, I have to go back to what I initially made my substitution for. So I said that 2x is equal to the sine of theta. So to find out what the theta is equal to, I need to take the inverse sine of both sides. So I know that the inverse sine of 2x would equal theta. So theta is going to equal the inverse sine of 2x. So making that substitution, I have 1/4 times the inverse sine of 2x plus, and I'm just going to bring out that 4 from the denominator as a coefficient in front instead of putting it all over 4. So I have plus 1/4, and I need to again determine what is the sine of theta equal to. So again, there's two ways to do that. We could look at the triangle, or if we already had sine of theta defined, we would just use that. Well, since I already had it defined, I know that the sine of theta is equal to 2x. So I'm going to replace sine of theta with 2x. Then I need to replace cosine of theta with something in terms of x. Again, I can either look at the triangle or see if I already have this definition. I already had the definition that the cosine of theta is equal to the square root of 1 minus 4x squared. So I replace the cosine of theta with the square root of 1 minus 4x squared plus c. Last thing I can do is really clean this up. So I have 1/4 inverse sine of 2x plus this becomes 1/2 x square roots of 1 minus 4x squared plus c. So the integral of this square root of 1 minus 4x squared dx is actually 1/4 inverse sine of 2x plus 1/2 x square roots of 1 minus 4x squared plus c. Let's look at the next example. Example 3. Again, I need to rewrite this integral using a trig function. Typically the ones we use are secant, tangent, and sine. So I have to determine what is given and which one of those trig substitutions works best. And then I rewrite it all in terms of the trig functions. So I have 1 plus x squared underneath my radical. Well, this is a number squared plus a variable squared, so that I know that my substitution should be tangent. So what I do first is I identify what a is and what u is. Then I know I need to let u equal a times the tangent of theta. So in my case, we're looking at x is equal to the tangent of theta. Then I build my triangle. If this is theta, what I know is the opposite side would be x, the adjacent side would be 1 because I have x is equal to the tangent of theta. And again, using Pythagorean theorem, I get that this side is 1 plus x squared. Now, I need to figure out what my substitutions are going to be. I'm going to take my integral, rewrite it over here. I have the integral of, well, this 9 is a constant multiplier, so I can pull that 9 out. So 9 times the integral of 1 over the square root of 1 plus x squared times x cubed times dx. So I need to determine what is the square root of 1 plus x squared, and what is x cubed, and what is dx. Well, looking at my triangle, if I want to find the square root of 1 plus x squared, I know that I'm going to be using the hypotenuse and the adjacent side. Well, the trig identity that goes with the hypotenuse and the adjacent side would be secant. So I know that the secant of theta is equal to the square root of 1 plus x squared all over 1, which means that the secant of theta is just equal to the square root of 1 plus x squared. So far, I can rewrite this as 1 over the secant of theta. Then I need to determine what is x cubed. Well, I know that I let x equal the tangent of theta. That means that x cubed would be tangent cubed theta. Finally, I need to determine what dx is. Well, dx is just going to be the derivative. So coming here, I know that the derivative of x is dx, and the derivative of the tangent is the secant squared of theta d theta. So dx becomes the secant squared of theta d theta. Well, if I clean up this integral, I'd end up with one of my secants here cancels. Tangent cubed theta times the secant of theta d theta. So what I need to do now is determine how I'm going to evaluate this integral. Well, I notice that the tangent is raised to an odd power. So when tangent is raised to an odd power, I typically save a secant tangent and convert to a power of the secant. So that's what we're going to do. So we're going to rewrite this as tangent squared theta times secant theta tangent theta d theta. Remember, this is what we're saving for our du. So what we're going to look at here is 9 times the integral of secant squared theta minus 1 times that secant theta tangent theta d theta. Now again, we're just going to make a substitution. We're going to call it w. If I let w equal the secant of theta, then dw here is going to be equal to the secant of theta times the tangent of theta d theta. So this becomes, 9 times the integral of w squared minus 1 dw. Well, that's something I can definitely integrate. So this becomes 9 times w cubed over 3 minus w plus c. Putting secants back in, we're looking at, and distributing the 9, 3 secant cubed theta minus 9 secant of theta plus c. The last and final step, again, is to get rid of the secant of theta and put that back into x's. We look here and we see we've already determined that the secant of theta is the square root of 1 plus x squared. So we can replace this with 3 times the square root of 1 plus x squared cubed minus 9 times the square root of 1 plus x squared plus c. And then here, another way of writing the square root cubed would be 3 times 1 plus x squared to the 3 halves minus 9 times the square root of 1 plus x squared plus c. So the integral of our original problem, which was 9x cubed over the square root of 1 plus x squared dx, is 3 times 1 plus x squared to the 3 halves minus 9 times the square root of 1 plus x squared plus c. Let's look at one more problem in this video. I have the integral of 4 over x squared times the square root of 16 minus x squared dx. So again, I first need to figure out, right, this is the given, and from this given, what should my substitution be? Well, it's going to be a number minus a variable. So that number minus a variable means that my substitution should be sign. Identify what a is and what u is. So if a squared is equal to 16, a would be 4. If u squared is equal to x squared, u would be x. And then I know I need to let u equal a times the sine of theta. So in my case, x is going to equal 4 times the sine of theta. If I solve for the sine of theta, I get that x over 4 is equal to the sine of theta. Then I use that to make my triangle. This is theta. So if we have the sine of theta, we know that the opposite side is x. The hypotenuse is equal to 4, and then doing Pythagorean theorem, we'd end up with this adjacent side as the square root of 16 minus x squared. So if I look at my problem, I know that, well, 4 is a constant multiplier. I can pull that out. I have 4 times the integral of 1 over the square root of 16 minus x squared times 1 over x squared times dx. And I just rewrote it there as well. So the first thing I want to do is I want to figure out what is the square root of 16 minus x squared equal to. Well, looking at my triangle, I know that that's going to involve the adjacent side and the hypotenuse. So adjacent and hypotenuse is going to be cosine. So I know that the cosine of theta would equal the square root of 16 minus x squared all over 4. If I solve for the square root of 16 minus x squared, which is what I'm trying to substitute, I get that 4 cosine of theta is equal to the square root of 16 minus x squared. So coming back over here, I know that I can replace the square root of 16 minus x squared with 4 cosine of theta. And I'm already going to go ahead and cross out the 4's because I know that those will cancel. Then I need to multiply that by 1 over x squared. So 1 over, well, I need to figure out what x squared is. Well, if x was given to be 4 sine of theta, I know if I square that x squared is just going to be 16 sine squared theta. So I have 1 over the cosine of theta times 1 over 16 sine squared theta. And then I need to figure out what is dx. Well, again, if I come here, if x is equal to 4 sine of theta, if I take its derivative, dx would equal, well, the derivative of the sine is the cosine. So I have 4 cosine of theta d theta. So I multiply this by 4 cosine of theta d theta. Well, I notice right away that my cosines will cancel and that I can reduce between 4 and 16. And that's going to leave me with a fourth. So we're going to go ahead and pull that fourth out of the integral. So I have 1/4 times the integral of 1 over sine squared theta d theta. Well, I know that 1 over sine squared theta is the same as cosecant squared theta d theta. And the reason that I rewrite it as the integral of the cosecant squared theta d theta is that is basic form. I can integrate the cosecant squared of theta d theta. The integral of the cosecant squared of theta d theta is equal to the negative cotangent of theta plus c. Sorry, that should be a positive 1/4 times the negative cotangent of theta plus c. Distributing the 1/4, you have negative 1/4 times the cotangent of theta plus c. So now what I need to figure out is what is the cotangent of theta equal to in terms of the variable x. Well, if I look here, I've defined what cosine is and what sine is, but not cotangent. But that's easy to do. All I need to do is look at my triangle. So cotangent of theta I know is going to equal adjacent over opposite. So I need to take the adjacent side and put it over the opposite side. So in my case, cotangent is going to equal the square root of 16 minus x squared all over x plus c. And then finally, just distributing, you're looking at the negative of the square root of 16 minus x squared all over 4x plus c.